Hello and welcome to Recharge with Solectria. This is the second of our webinar series, and the topic today we're going to talk about is inverter fault resolution. My name is Jeff Ryan. I'm the Regional Sales Manager for the Southeast and Mid-Atlantic regions for Yaskawa Solectria Solar. With me today are technical support engineers Ryan Plucinski and Josias Robles. You may get one of these guys when you call into tech support if you're not familiar with them already. If you have any questions during the webinar, please put them in the questions tab, and if time allows, we'll take your questions at the end of the webinar. First off, I'd like to talk about who Yaskawa Solectria is, and then we'll get into the meat of the webinar about inverter fault resolution. Solectria was originally founded and established in 2005 in Lawrence, Massachusetts, and that continues to be our headquarters, where we have our engineering and some of our sales offices. Lawrence is about 30 minutes north of Boston. Our inverter manufacturing is done in Buffalo Grove, Illinois, which is about 45 minutes northwest of Chicago. I'd like to make it known that we're the only inverter manufacturer that manufactures in the U.S., is engineered in the U.S., and has our technical support based in the U.S., which is in Waukegan, Illinois. Solectria Solar was acquired by Yaskawa America Incorporated in 2014. As you can guess, that's when we changed our name to Yaskawa Solectria Solar. Just as a reminder, when you're at a trade show and you're trying to look up our booth number, we're always at the bottom of the list as we're listed as Yaskawa Solectria Solar. In our 21 years of building PV and energy storage inverters here in the U.S., we remain committed to delivering the highest quality inverters. We're currently the largest U.S.-based inverter manufacturer of both PV and energy storage inverters. We're probably best known for our made in the U.S., FIAT compliant XGI 166 and 250 series of string inverters that do qualify for the IRA bonus. As I mentioned, these are manufactured in Buffalo Grove, Illinois. The sizes of our XGI inverters range from 125 kilowatts to 250 kilowatts. These are 1500 volt DC, so they're for ground mount applications. But as a reminder, they can be used on carports or canopies, depending on whether your AHJ views them as ground mounts or structures. The majority of our XGI inverters have 600 volts of AC output, but we do have 175 kilowatt and 200 kilowatt models that have a 480 volt output. We also have our PVI inverters, which are 1000 volt DC and range from 25 kilowatts to 60 kilowatts. These are typically used on rooftops for commercial and industrial applications as opposed to ground mounts. The PVI line is compatible with AP Smart Rapid Shutdown devices, which we also offer. We offer a full line of DC combiners that you can use with or without our XGI 1500 volt series of inverters. We have both 250 and 400 amp options, as well as attachable and remote combiner boxes with optional output fusing and various fuse amperages. These are all made in Franklin, Wisconsin. And although it's not required for FIAC, they would be considered FIAC compliant. We're excited about our new XGI 1500 1 megawatt central inverters, which we're currently quoting for a mid-2027 delivery. We're offering UL listed nameplate ratings of 499 kilowatts, 500 kilowatts, 750, 850, a 999, and a 1 megawatt. This inverter will also have the flexibility to be AC or DC coupled for energy storage systems. If you'd like to learn more about the 1 megawatt, please reach out to your regional sales manager. We also have our power racks. These are powder-coated steel racks that can accommodate 2 to 8 inverters and are pre-wired with a project-specific AC combiner. Our power rack solution is 100% U.S. domestic content and fully BABA compliant if you do have federal or municipal jobs. We also offer our PVS 500 system, which is a 500 kilowatt DC coupled energy storage system, which we've offered for about 4 years. I'll turn to Yaskawa now, and you guys can advance that slide. Thanks. Which is a Japanese company. It was founded in 1915, so Yaskawa is over 110 years old. It's publicly traded on the Japanese stock exchange and has roughly 15,000 employees worldwide. We have a sales and service, as well as manufacturing in over 30 countries. We've sold over 250 million servo motors, 350 million VFDs or variable frequency drives, 6,000 robots, and have over 4.5 billion in yearly sales. I'll hand things over to Ryan.
Thank you, Jeff, for that introduction. As stated at the beginning of this presentation today, Josias and I will be discussing common fault codes that customers call us for in regards to the XGI 1500 inverters. For the most part, these codes will be applicable to any XGI inverters under the 1500 family. As the composition of this presentation, the most commonly installed inverters are from the 166 or 200 series. At the end, as Jeff mentioned, we will have time to answer questions, so anything that you can think of to ask, please type it into the chat and we will try to answer as many as we can. That being said, before we get into any codes, we do want to discuss a few things. The first being useful equipment that we recommend technicians bring to site, as well as components and power flow within the inverter. So equipment and information. The first thing we have listed here are baseline pieces of equipment. Those being a Cat 3 multimeter rated to measure 1500 volts. An example being the Fluke 393FC, a laptop with an available Ethernet port, and spare Cat 6 Ethernet cables. Items listed as the baseline are essential, providing the basic information and performing standard troubleshooting on XGI inverters. While yes, the inverters do have the capability to emit a Wi-Fi signal, it is always best to have a laptop to be able to hardwire into the machines. Not only to get information from the unit, but for uploading firmware, we always recommend a laptop be used. Next, we have the optional pieces of equipment. Again, we highly recommend these be brought to site, but as you can see, we additionally recommend a multimeter capable of testing diodes, an example being a Fluke 87V, a phase rotation meter, a mega ohm meter, and an Ethernet coupler. For the items listed under the optional category, while technically not needed to provide basic information, as we will discuss when we get into the actual codes, these pieces of equipment can be used to alleviate potential revisits and in turn reduce downtime for the inverters. Last thing here is information. Now, when you guys call us, typically the first thing we're going to ask for are going to be the inverter serial numbers or inverters that you are working with at that point, as well as the address of the site the equipment is located at. Especially if you've never called us, this will for sure be coming up at some point in our conversation.
Okay, thanks, Ryan. So now, looking into the actual equipment, the XGI 1500, what components does this unit have? What am I looking for? What do these components do? That's what we're going to go over right now. So basically, first it all starts with your DC terminal block. The customer lands the positive, negative feeders coming from their CB on the array side on that terminal block. And basically, this is a DC powered inverter. What that means is if we don't have any DC voltage present, the unit's going to automatically shut down. You're not going to have any lights, LEDs on the inverter or anything like that. It's not powered off AC, but DC. And if you take a close look, it goes through the DC switch or your DC disconnect. Once that's engaged, the voltage is going to pass through what we call the arc fault CT. This CT is only found on certain units. Typically, the 250 or CCL inverters are the ones that have this. But essentially, as its name says it, that is in charge for arc fault sensing. From there, all XGI inverters have what we call an IMI board. If you can see my mouse or anything like that, but it's the one in the blue at the top next to that arc fault CT that is for ground fault sensing. Once the voltage passes through there, we come to our DC power supply. So basically, starting with troubleshooting procedures, if you arrive on site, your inverter is completely off, you have other units on site that are producing just fine, full sun, and the unit's completely dead, first, obviously, check to see if there's any DC voltage present. Maybe the combiner was turned off or anything like that. But if there is voltage, then where you want to start testing is your DC power supply located on the top right corner in the image that is being presented. It is recommended to check the DC voltage coming in to that power supply and then the small signal voltage DC coming out to the boards. So just an FYI, if you ever encounter a unit that is completely turned off. From there, it goes directly to the AC filter capacitor banks. And from there, this is where the magic happens. We got our IGBTs. This is where the conversion from DC to AC is happening. So from here, it converts to AC. And then as you can see in the next slide, it passes through your current CTs for each phase. From there, it goes to the bag, to the inductors, and it comes out through the EMI filter on the bottom left corner, through the contactors, and directly out to the grid. So this is just the general power flow chart of what is happening with your XGI 1500 inverter, what the components are, what they're called, how we're going to be referencing them over the phone, but just an idea of what we're looking at. Now we're going to go into some inverter event and fault codes, and I'll pass this over to Ryan.
Okay, as Josias mentioned, now that we have gone over the basics, we are now going to discuss some codes that you guys may encounter. These are mainly in order of by classification and don't necessarily reflect how common or often they occur. The first code we're going to discuss here today is Warn 2, phase lock loop failure. Now, the word failure can come off as harsh and exaggerate the situation. When the inverter shows this code, essentially it believes that either a phase is missing, over range, or rotation is out of sequence. This code might come up during the commissioning process, especially if you don't have PTO. In that case, it is more of a byproduct of the current situation, as there just is no AC present at the inverter. Now, as for recommended troubleshooting, the first thing you would want to do is turn the inverter completely off using the local DC disconnect found on the front of the cabinet exterior and the AC switch found on the right-hand side of the cabinet exterior, and test for AC voltage. The par value for AC voltage will either be 480 or 600 volts phase to phase and 277 or 347 phase to ground, depending on the inverter class you have installed. Now, that being said, these inverters have programmable AC voltage ranges that it will adhere to that can go above or below the par value. When the inverter is fully energized for the first time, you close both AC and DC, or the inverter goes through a restart, meaning you power cycle it or it's recovering from a fault. At that point, the inverter goes through a 5-minute UL countdown. It will observe and adhere to the recovery settings parameter window, which you can see on the screen here. For VAC specifically, the range I mentioned will fall between the high voltage and low voltage set points. This brings us to our next recommended troubleshooting step. Now, especially in the event you are able to measure voltage at the customer connections inside of the inverter cabinet, the issue at that point is possibly phase rotation, at which point we recommend to see if this code is isolated to just one inverter or the entire pad, as the simple solution is to rotate any two phase conductors, for example, phase 1 and phase 2, L1, L2, phase A or phase B. Where that takes place can either be at the distribution panel or the inverter cabinet. It sort of just kind of depends on the extent where you're seeing the codes. Referring back to our equipment slide, under the optional category, we listed a phase rotation meter. Hooking that device up to the AC conductors in the inverter would allow you to verify the current phase rotation. And as mentioned on the slide, the XGI inverters want the rotation to be clockwise. Possible components that could be an issue, especially if all the AC voltages are lining up and you have confirmed that rotation for the phases is clockwise, would be the K2 contactor, the DSP board, or the interface board. The K2 contactor needs to close for the inverter to see voltage. The DSP board needs to send control voltage to tell the K2 contactor to close, and the interface board is responsible for displaying voltage on the GUI.
Okay. Another fault you guys may encounter is warn for open phase detected. Specifically, this code can mean different things depending on the hex value it's giving you in the event and fault log. Right now, we're going to be focusing on no AC, zero current crossing. A quick tip, when you're troubleshooting the XGI inverter, if it's in a fault state, if you go to the event and fault logs and you hover over the fault code, this will give you further or more detailed information to what is going on with your unit. As you can see in the picture, when you hover over the fault code, it says bit 0, no AC current, 0 crossing. And then it says bit 14, phase B detected. This code can also be tied typically with a crit 13. And what it's 90% of the time, what it's going to be pointing to is a problem with one of your CTs, the current sensing devices that are after the IGBTs, as we saw earlier in the presentation. As I mentioned, typically you'll see the warn 4 tied with a crit 13, and if you hover over the crit 13 fault, as you can see in the picture, it says current sensor offset fail phase B on startup. So that means that this phase B CT is not functioning properly and is what's causing the unit to fault out. Now, if your inverter is producing power, it's running perfectly fine, but you see these fault codes in the past, a quick troubleshooting step you can do is if you go to the live measurements, under AC measurements and current, you will notice that there's going to be a current imbalance. As you can see in the picture, phase A is showing 54 amps, phase C is showing 54 amps, but phase B is showing 35. So right off the bat, you know that phase B has a CT problem issue and it will need to be replaced.
Next code here is warn 9, AC low voltage detected. Essentially, the inverter is seeing low AC voltage. Similar to a warn 2, this is one of the codes you might see when you first turn the inverter on for the first time, especially during the commissioning process. But again, at that point, the code could possibly be a byproduct of the situation, as typically during the commissioning process, there is no AC voltage present at the inverter. This is why I mentioned on this slide it is important to know when the code is happening, meaning does it happen while running or at startup. As for recommended troubleshooting, you would want to start by turning the inverter completely off, opening it up, and testing for AC voltage at the customer connections. If right away you are seeing a strange value on your meter, this issue may be external from the unit. If the values are close to what the inverter wants to see, you can turn the inverter on and proceed to the second recommended troubleshooting step, that being to log into the inverter and check the live measurements menu. If you are seeing values on the measurements menu, similar to how Warn 2, along with the recovery settings, you can also look at the abnormal AC voltage detection parameters found under the inverter functions and AC voltage and frequency trip settings, which is the screenshot you see on this slide. This is important to view, especially if this code is occurring during the day as opposed to at startup. If the AC voltages are dropping below the programmed threshold, then Warn 9 will record under the inverter's event and fault log. In terms of possible components, again, we have listed here the K2 contactor, the DSP board, or the interface board. Again, the K2 contactor needs to close in order for the inverter to see AC voltage that may be present at the inverter. The DSP board signals the K2 contactor to close, and the interface board is what is responsible for displaying the AC voltages in the GUI.
The next code you may encounter on site is Warn 12 AC high voltage detected. Now, it is important to point out that depending on your inverter, the specifications are going to be different. The XGI 1500 166 series is a 600 volt AC three-phase inverter, and it has a voltage range of minus 12% to up to 10% positive. What this means is when the unit has grid connected and is producing power, the 600 volt AC inverters can go up to 660 volts AC while grid connected and producing power. As for the XGI 1500 250 series, for the 480 volt AC option, that would be 528. When the unit has grid connected, it can go up to 528 volts AC. Now, it's important, we never want to go above either 660 volts AC or 528 volts AC. If we do, we're going to get this Warn 12 high AC voltage detected fault, and that may result in damaging the inverter. There's a second variation of this fault code, and it says AC high voltage reconnect. And this code is going to typically come up or pop up when the unit is trying to wake up in the morning and grid connect. Or if the unit faulted out and it's trying to restart and you get this code, it's a reconnect fault code tied to the recovery settings of the inverter. As I mentioned in the previous slide, the unit can go up to 660 volts AC or 528 volts AC when the unit has grid connected. And what we're referring to when we say grid connected, it means that the unit is on and producing power. If the unit is in a fault state or it's waking up, the recovery settings are what kick in on your inverter. And the 10% goes away and it's a 5% value, what the inverters have. So for a 600 volt AC inverter, that would mean that your voltage when the unit is waking up in the morning, or if it faulted out, it has to be below 630 volts AC. For a 480 volt AC unit, the voltage needs to be below 505 volts AC. And what's going to happen is if in the morning the voltage is higher than that 5%, the unit is trying to grid connect. But since the value is higher than the recovery voltage settings, it's going to fault out with Warn 12 AC high voltage detected. And again, if you hover over the fault, it says high voltage reconnect. That means it's faulting out because of your recovery settings. And the voltage needs to be lowered to allow the unit to kick on and grid connect properly to start producing power.
The next code we'll be discussing is CRIT9, Critical Internal Hardware Failure. In contrast to previous codes, there isn't really a definition, as the code for the most part speaks for itself. Essentially, an internal component within the inverter has failed. Symptoms and observations you might expect to see at this point will be, for one, the inverter will cease operation, and the external warning and fault LED will illuminate. This code can indicate different issues depending on the adjacent hex value it displays in the event and fault log. The code itself is more direct than others we've previously discussed, in contrast where other codes may be byproducts of the situation. For example, if crit 9 occurs, you may also see some corresponding warning codes that we have previously mentioned. The hex value recorded can allude us to the particular component that may have failed, but given the nature of the code, it could be one or more. In terms of troubleshooting, you would want to start by turning the inverter off and performing a visual inspection of the cabinet interior to verify nothing has obviously been broken. With the inverter off locally, we would then recommend you test DC and AC voltages at the customer connections. Now at the bottom, I list possible components that could be in question when crit 9 results, those being the IGBTs, the CTs, the DSP board, the interface board, or the power supply. If the technician calling us is trained, we can have them perform a static internal check on the IGBTs using the documentation they receive upon completion of the course, but we can resend said documentation if need be.
Crit 5. As its name says it could be related to a contactor failure. First, we need to identify, again, if we go to the event and fault logs and we hover over the fault code, this will tell us specifically which contactor it's referring to. So, in this picture, it says that the K1 failed open, so the issue would be with the bottom contactor. If you look at the picture, every time you call in and we say, can you check the K2 contactor, we're always referring to the top one. When we say check the K1 contactor, we're referring about the bottom one. So once we've identified which contactor is causing the issue, in this scenario, K1, the bottom one, what we need to start off with is check the signal wire connections. You're going to notice if on the right-hand side of each contactor, you have some signal wires. These signal wires are coming directly from your DSP board, which is basically stands for Digital Signal Processing Board. This signals the contactors with a signal voltage of approximately 24 volts DC to allow the coil inside of the contactor to close in and then allow the full voltage to pass through. What happens is if those signal wire connections on the right-hand side, they're red and white, if they are loose or making a false connection, that signal voltage is not going to be sent properly to the contactor, and it will result in the contactor not closing in and the inverter faulting out with this crit 5. So what is recommended is inspect your connections, A1 and A2, the little red and white wire, make sure they're tight, they're plugged in, and then power cycle the inverter to see if the error code goes away. If it doesn't go away, then the next step is to check continuity on the contactor tab. Now, important, this has to be done with the unit completely de-energized. And what we mean by that is the technician's going to have to go to the AC panel and turn off the breaker that feeds AC voltage to the inverter. Likewise, they will have to go to the DC combiner box, turn off the combiner so there's absolutely no AC or DC voltage going to the inverter. Now that the inverter is in a safe state, they can manually, with a screwdriver or something, push in the contactor tab and then test continuity on each phase, top and bottom. If it rings out, you know the contactor is good, and it may be related to the signal voltage they're getting. This is going to lead us to our last and final step, which is signal voltage testing. You can power cycle the inverter, and once the unit has finished its 5-minute countdown, like I mentioned, the digital signal processing board is going to fire a 24 volt DC signal voltage to the contactors to allow them to engage. So if you test after you've power cycled the unit on the top contactor, K2, that's typically the one that will engage first, always. After the top one has closed in, the bottom one, K1, is the one that closes in. So if it's finished the power cycle, you can test to see if there is signal voltage present. If there is signal voltage present and the contactor tab is not pulling in, you know it's going to be definitely a bad contactor. If there is no signal voltage present, then that may be related to a wire harness issue or the digital signal processing board has failed.
Okay, so next we're going to be discussing ground fault alarms. There are 3 different ground fault codes the XGI inverters can record, those being CRIT 7, 8, and 10. As you can see in their definition, each code represents a different condition. The first of which is CRIT 7, excessive leakage current. Now this code can occur on all XGI 1500 inverters, but specifically for the DCG model, this is the code you will see when the internal GFDI breaker trips. Next would be CRIT 8, insulation resistance low. This code specifically implies a low insulation resistance value is being detected on either the positive, negative, or both DC conductors. This is a true ground fault or array side issue. Lastly, here is CRIT 10, self-check failure. This code implies something in the ground fault's detection circuit has failed. Again, we always want to verify nothing external to the inverter has caused this. The primary component inside of non-DCG XGI 1500 inverters that detects ground faults is the IMI sensor. The IMI sensor is a CT that wraps around the positive and negative DC conductors within the interior of the inverter, and the sensor itself is looking for a delta in current of essentially 0. There are several ground connections throughout the cabinet interior that you should inspect and verify they are properly seated when CRIT 10 occurs. Those being J23 on the DSP board, J2 on the interface board, J1 on the DC-MOV board, and J2 on the DC discharge board. The connection between the DSP and the DC discharge board, J10, if not seated properly, will result in a CRIT 10. For that matter, if any component in the circuit is unplugged, it could result in a CRIT 10 occurring. As for recommended troubleshooting, we would ask you to start by turning the inverter off locally using both disconnects. Leave the combiner box engaged, and then proceed to test DC voltages to ground, both positive and negative. Now for non-DCG XGI inverters, the array is considered floating, so the longer you hold a reference to ground from either positive or negative, the voltages should proceed to bleed out towards 0. After you've verified that voltages bleed, we recommend you disengage the DC leads, we recommend you turn the combiner off and disengage the DC leads from the array. Proceed to perform insulation resistance testing on the array in accordance with the panel manufacturer. As recommended in the troubleshooting steps, we always want to eliminate the possibility that this is an array side issue. During testing, since you will need to open the inverter, it is in your best intention to perform a visual inspection of the cabinet interior to verify nothing is obviously damaged. And as mentioned previously, there are internal grounding connections that need to be properly seated. Referring back to our optional equipment list, we did recommend a mega ohm meter be brought to site. In this event, it would be very useful to avoid a revisit such that you can test the insulation resistance on the DC conductors, provide those results, and then we can proceed accordingly from there. As mentioned with CRIT 8, the inverter can indicate which pole is detecting low insulation resistance, but this is a calculated value. There is not a component inside of the inverters that is injecting anything back onto the array. In terms of possible components within the inverter that could be in question, I have listed here the IMI sensor, the IMI sensor harness, the DSP board, or the interface board.
And this leads us to our last common fault code that you may encounter on the XGI 1500 inverters. And that's going to be Info 6, external fan damaged. And as its name says it's pretty straightforward. There's a fan that is not functioning proper or has failed. So again, as we've been going through this, these presentations or slides, first we need to identify what fan has failed. So we head over to our events and fault logs, we hover over the fault code that we're getting, and as you can see in the picture, it says fan 3 feedback error. Now, if you get a bit 0, it's going to be fan 1, bit 1, fan 2, feedback error, and a bit 2 is going to be fan 3, feedback error, as the picture shows. Now, you may think, well, the top fan is fan number 1. It is not. It's fan number 3, the middle, fan number 2, and the bottom, fan number 1. So now that we've identified, going back to the previous slide, fan number 3 is the one that has failed, we go to our top fan, and what's recommended is a fan swap. So basically, if fan number 2 is running with the unit off, we grab fan number 2, we put it in position of fan number 3, and vice versa. Fan number 3, put it in the position of 2, and fire up the inverter. If the code changes, and now it's showing fan 2 feedback error, and the middle fan stopped working, you know the issue followed the fan, and it's a bad fan that needs to be replaced. Now what happens if we do the fan swap, but the issue remains in the same position? Well, this may be a voltage issue or a wiring harness problem. And to test that, we recommend to check continuity on the fan harness. It is recommended to do this troubleshooting procedure that the technician has fine leads, as you can see in the slide on the top right corner, to be able to test the connection points. Since with regular leads, it is not going to be possible to perform this troubleshooting procedure. I'm going to explain what the pictures are referring to. If you go ahead and you remove the pin from the actual fan, the wiring harness is going to show on the right-hand side, looking at the picture on the right-hand side. For fan 3, let's say fan 3, the red arrow is pointing to position or pin 15. So you would put your positive lead there. If you're testing fan 3, put your positive lead there, and then on the other end, this connector on the left side connects directly on the bottom of the interface board. It gets removed, so with your positive lead on pin 15 for testing fan 3, you would then put your negative lead on pin 15, as you can see below. If it rings out, then you know there's continuity and the fan harness is fine with that specific position. From there, you can now move to pin 5 if you're still testing fan 3. You put your positive lead on where the black arrow is, and then you head over to the other part of the harness, and you locate pin 3, which is right here. You test continuity. If it rings out, it's perfectly fine. You can follow those procedures, and if you have continuity on each pin, you know the harness is going to be fine, and that is going to mean that there is a voltage problem with the board, and that is going to be related to the interface board. The interface board will need to be replaced. Now I will pass this over to Jeff.
I did want to highlight the fact that we do in-person trainings. It's our hands-on training. And if you visit Solectria.com and click over to our trainings tab across the website, you'll get additional information, and you can link there or click there and then register. We do also have e-learning modules that are listed on the website. You know, and then we have the recorded webinars as well. And then we also have our YouTube site where you can go to YouTube, and if you just do a search for Solectria, we'll have different videos listed there. And we do have our recharge of our previous webinar that we did on demand, and that's based on FIAC, and that was from January of last year. Let me see if we have any questions. It looks like, and then lastly, actually, I did mention earlier that we do have our 2 facilities in Buffalo Grove and then in Franklin, Wisconsin. We will be moving our headquarters to Franklin, Wisconsin in the next probably 3 to 5 years and building out a campus there. But for right now, we still do our manufacturing and shipping from Buffalo Grove, and we do offer tours of that facility. It is a pretty cool facility. Not only do we do manufacture our inverters there, but we also do our motion drives and some of our robotics. So if you are interested in getting a tour, please reach out to your regional sales manager and they can line that up for you. As far as questions, let me just see here. We've got something where we'll be offering more dates for the hands-on classes. They seem tough to get into. We have hired another trainer, and right now the trainer is we're doing private trainings. So as soon as we knock those out, we will be adding some dates to our trainings. Let's just see. Did I miss anything else there? We've got a question that maybe Ryan or Josias can take. Can we modify the recovery settings for high recovery voltage?
Yes, you can. That being said, you would likely need prior approval from your utility. But as far as the threshold goes, when you're actually on the parameter page, you will see the visible range that you can set the parameter to on the screen itself.
Okay, we're seeing another question.
It says, I'd like to provide third-party service in Texas, Oklahoma, and Arkansas. Who would I contact? We had one tech go through your XGI training. Tim, I would say reach out to John Lavelle, who is your regional sales manager, and he can direct you to as far as doing some third-party service. We don't have a formal program for that, but we are working on doing something like that in the future once we get more people trained.
There's another question here from Peter Adams. Is the in-person training still a prerequisite for handling and working on the XGI or the Solectria inverters? Yes, we still require technicians to have completed our training course prior to replacing parts. But that being said, you can still call us and troubleshoot the inverters. We would just simply need to set it up for service to have one of our field service technicians come to site and actually replace the parts.
I see there's a fourth question right there. How do we connect to the inverter's IP address? By Steve Ferris, I believe. So the inverters, they come from factory set to automatic DHCP. There isn't a specific IP address that you need to specify on your laptop unless your team has specified or blocked out one of the ports of the XGI inverter through the Ethernet network configuration settings. If you haven't done that, then just make sure that your laptop is not set to a static IP, and via Ethernet, you can plug into any one of the ports, go to a web browser, type in xgi.solar, and that should automatically be able to pop up the graphical user interface.
I see another question as far as having our trainer come to your site. That is not possible because we do have the training is very hands-on, and we have several of our inverters there on site. So we do our trainings at Lawrence, Massachusetts, or at Waukegan right now. Again, that will be moving to Franklin, Wisconsin sometime in the future. But we need to have those inverters connected to some kind of power. And again, we have our labs already set up for all of that. So yeah, that's why we do them on site at our facilities. I got another one. If I need assistance with my XGI inverter, how can I get assistance?
Yeah, so we always recommend you call us. Our phone number is 978-683-9700, extension 2. For troubleshooting the inverter, it's always recommended to actually be on site, but Again, we're available from 7:30 a.m. to 5 p.m. Central Time. If you want to call us before going onto site to get confirmation that we need you there, by all means, we can answer that for you on the phone. Alternatively, if you just want to get a dialogue started and get just general information about how to proceed, we do have an email. Our email is support@solectria.com.
We've got another one. Is there a way to change sensitivity on the arc fault sensor through the inverter settings?
No, there is not a parameter to manipulate the sensitivity of that CT.
Yeah, that will all be that is all taken or handled through the inverter's firmware. Unfortunately, that can't be modified.
What's the typical dispatch time for your field technicians? I can take that one. We basically have them scheduled by midweek for the following week. So it kind of just depends on how busy they are, as well as when you're calling in with some kind of technical issue. So it could be, I would say it could be as short as a week. It could be as long as maybe 2 to 3 weeks, depending on the workload and what time of the week you're calling in, and whether they've been their schedules have been set for the following week. Another question: the inverter can fail due to an unbalanced load on each phase. What is the maximum imbalance allowed?
I would need a bit of clarification on that one about what you mean specifically. Are you referring to the voltage or the current when you refer to load? If you're referring to voltage, typically these inverters are pretty hardy in terms of compensating for unbalanced voltages. As long as the values fall between either the recovery settings or the abnormal AC voltage parameters, then it should be able to continue to produce at that point. In terms of current, I'd have to get back to you on what the allotted tolerance is in terms of an imbalance. But typically, if there is an imbalance, like we mentioned when we were discussing codes, you may expect to see a CRIT 13 alarm occur.
Thank you. What is the process for extending warranty coverage? Our policy for extending the warranty coverage is that when you procure the inverters, you do need to procure the extended warranty at that time. You cannot come back at a later date and extend the warranty. Can we purchase replacement parts in advance for our inventory to reduce downtime? Our Yaskawa sites equipped with Yaskawas have seen a high breakdown rate. Every warranty claim adds a week to the downtime. So we do have, we do sell a spare parts kit, and the spare parts kit covers the majority of the components that have high, or I should say, that could possibly go wrong and can be replaced, or can go bad and can be replaced within the inverter. We do also through quotes or through service at Solectria.com or quotes at Solectria.com, you could purchase additional components if you wanted to. So basically, yeah, you have one of those two options. The best thing to do if you did want to try to just procure certain components would be, I guess, to talk to tech support, get the part numbers for those, and then go to quotes or service and get and order those parts.
And to sort of expand on that, if you are going to be utilizing parts from that spare parts kit, we do want to know the corresponding serial number that's printed on the label of that kit so we can proceed with any warranty claims appropriately.
That's about it, and we're coming up on the hour. I just want to say thank you to everyone that did join our webinar. And we will have another recharge with Solectria coming up next month, or excuse me, not next month, but we're doing them every other month. So the next one will be in May of next year. So again, thank you very much for tuning in, and look forward to recharging with you in the future. Cheers.